Here we're looking at the guided notes for 2.5, and this is going to be about making scatter plots, finding lines of best fit, and ultimately we'll get to linear regression. But before we do that, there's some things we need to really know and know pretty well first. So bivariate data is data with two variables. Right? Take the word bi out of there and you get variate, or variables, bi being two variables. So this type of data can be compared. This type of data can compare any two sets of data. So any two things that you think are related, you can try and see. So age and height. That wouldn't really work because there's old people that are tall and old people that are short, and there's young people that are tall and there's young people that are short. So that might not really work. It might be something silly to do, but really in general, we basically can any two measurables about one scenario. Any two measurables should give us bivariate data. We often represent bivariate data as ordered pairs that can be graphed as a scatter, or better known as a scatter plot, but sometimes called a dot plot. We could describe the correlation between the variables as strong, weak, or having no correlation whatsoever. Oh, what do I mean by that? Well, correlation is positive when the values increase together, and correlation is negative when one value decreases as the other value increases. So by that, here we have these lovely graphs. There's 7 of these graphs here. The first graph, it gives us a correlation of 1. Here's our correlation values here. These are the correlation values for each one of the graphs. And so for this one, it's a perfect correlation. All of these lie on a line, so this one would be perfect. Perfect correlation. And it's positive, right? Here we have a strong. Ooh, that was not good. Here it is a strong correlation. That's weak. 0 tells me that there is no correlation. Now this one is weak. It's weak and negative. This was weak and positive. This was strong and positive. In other words, as these numbers get bigger, these numbers get bigger. As these numbers get bigger, these numbers sort of get bigger. Oh, as these numbers get bigger, there's no telling. So there's no correlation whatsoever. But as these numbers on this graph get a little bit bigger, as they get bigger, these generally get smaller. And for this one, we have a strong negative correlation. It's strong and negative. As these values get bigger, these values get much smaller. And here we have a perfect negative correlation. Perfect. There's a perfect negative correlation with this one here. As these numbers get bigger, these are absolutely getting smaller, and it's perfectly on a line. There's some more information there on your guided notes about correlation. Make sure you give it a browse. It's got some good information there. All right, on the back side here, once we make a scatter plot, by closely approximating a line of fit, we can make a prediction equation. A prediction this is done by picking any 2 points. All right, so we take 2 points, y1 and or x1, y1, and x2, y2, and then we can make a line from that. And that's something that we've done all throughout the last unit. Since this is a matter of personal judgment, some lines differ from others. So, we have an example here. Yes, this is one of your homework problems. First, it says to make a scatter plot, describe the correlation, create a line of fit, and write a projection equation. Then use the equation to predict the missing value here. So, first thing, I want to make a scatter plot. Before I do that even, I need to scale this thing. So, depth and temperature. What should we do? I'm going to put depth over here. I'm going to say this is my depth. And over here is my temperature. And this is in Celsius. Okay, so what is my data? Well, my depth goes 0, 300, 500, 1,000, 2,000, and 2,500. So, 5, 1, 1, 15, 2,000. Now, that wouldn't use up my space real well. So, if I make 500, 1,000, 1,500, 2,000, that'd be 20. Oh, so I could fit everything I need on this. If I say this one here, that's 500, and this one's 1,000. Here we have 1,500 and 2,000. That tick mark and this tick mark will be 2,500. Alright, so temperature, my range for temperature goes 22 all the way down to, well, we don't know, so 0 to 22. This will be 0. So does 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 22 would be up here. So if this is, well, let's go 5, 10, 15, 20, 25, 30. That's too much. 3, 6, 9, 12. Do I have a bunch of... I have a 6. That's the only one that fits in 3s. Well. So for 22... You know what? Let's just do that. Let's do this in 2s. So I have 2, 4, 6. This would be 8. 10, 12. This is 12. 14, 16. 18, 20. And this keeps going. Let's just know 22's up here somewhere. Alright, so my first point, my depth is 0, my temperature is 22 degrees, so here my depth is my x-axis is 0, and my y-axis, so I'm at 22, so here's my point. That's my first dot. At 300, my depth at 300 is at 20, so there's 250, so 300 is right about in there at 20. And then we have at 500 it's all the way down to 13, so 500 will be right there at 13. 12, 13 is in the middle, and then 14. Yeah, that works. At 1,000, my depth is 1,000, my temperature is at 7. So that's right there, halfway there, right there at 1,000. Okay. At 2,000, my temperature is 6. So here at 2000, my temperature is right around, right there at 6. Okay. And at 2500, we don't know. Did it really skip from 1000 all the way to 2000? Dang, that's crazy. Okay. So now we can describe the correlation. Well, here's our scatter plot. And we should, in theory, be able to describe our correlation here. Our correlation, which one of these does it look the most like? It's probably somewhere between weak and strong, and it's more on the negative side, right? I mean, this looks to me that this is going to have a negative slope. Right here is going to be negative. So I would probably, and I would say this is going to have a strong. So we'll say strong negative correlation. Now, in class, the first thing we're going to do is talk about exponents and take a quiz. And then we're going to do part C and D together in class. I want to see what kind of lines we have. So if that's something you want to do now, you can. And use that equation to predict your missing value for 2,500 feet. That works. However you want to do that, it's A-okay by me. Otherwise, just wait until class, and then we'll finish off part C and D. First thing. Second thing after the quiz.